Okay, so we are continuing our notes on page. Let me write it over here. We are on page 30, I believe. Remember, it's in this tiny little corner down here, so it kind of sucks, but we are on page 30. So we're going to take these notes about matter and atoms and pure substances and what kind of all these terms are. It's a lot of terms, but hopefully it's a review, and it's just things that we kind of need to know in order to understand the topics that we're going to be covering. Okay, so we have matter. The first part about matter, we need to know what an atom is. And an atom is the smallest particle you can have of an element. No, not an elephant, an element. There you go. So an atom is like those single units that make up a compound or mixtures, which we're going to learn about down here. But atoms are part of an element. So when you think of an element, you can think of like hydrogen, oxygen, carbon, nitrogen, any of those things. So what is matter? Matter is anything that has mass, so you can weigh it or put it on a scale, and it takes up space. So anything around us right now that has mass or takes up space is considered matter. So you are made of matter. The pen or pencil that you're writing with, your Chromebook, all those things are like created from matter. From this term of matter, so we're going from basic into more specific. This is like an upside down pyramid. So we're going to start with things that are considered pure substances. Things that are a pure substance is that matter, or like what makes something a pure substance, is because matter that cannot be separated into different kinds of matter by physical means. So you can't just break it apart. And break it, you can't just like divide it. It can't be separated by anything physical. You would have to do something chemically to it in order for it to change. So two things that make up pure substances are elements and compounds. So we're going to start with element first. An element is all of the same kind of atom. So all hydrogen atoms, all oxygen atoms, all of the same kinds of atoms. And they cannot be broken down by chemical or physical means. So an element exists as itself. It cannot be separated. It cannot be broken apart. It's just one of itself, and that's how it exists. So a picture representation would be just all these little atoms floating around in space, kind of hanging out, doing their thing. So that would be a picture representation. And then an example of these things would be things like oxygen. These are all elements that you can find on the periodic table. So when you go in and take chemistry, these are all like on that periodic table that you'll see in the classrooms. There's hydrogen, which is the letter H, or something like iron or gold, Fe. So if you ever see these little letters after the word, that's just what they're known as on the periodic table. So then let's go back to a compound. So this is all an element. That's all the definitions of an element. And then we have definition of a compound. Now, a compound can also be known by the term molecule, which is a lot of times how we'll be referring to it as. So I want to make sure you write that down so that you know that compounds can also be referred to as molecules. So a compound or a molecule is two or more elements chemically combined. So they were put together. They are the same composition throughout. So it looks the same throughout the entire unit or whatever you're looking at. So a picture representation, it's going to have, this would be an element, like one, blown up, and then it has another element attached to it. So these are probably like little water molecules. They kind of look like little Mickeys or little bears or little frogs. I'm not really sure. You can't see these with the naked eye, so it is just a picture representation so that you can kind of think of what it might be. So there's the picture representation. So it's one kind of element combined with another kind. So the open circle with the closed circle. So examples, I already told you something like water would be one, or anything that has more than one element combined. So here we have two hydrogen atoms. Remember hydrogen over here. combined with 1 oxygen atom. So this one technically has 3 atoms combined. So that's why it says 2 or more. So that is all of our pure substances, something that cannot be separated into different kinds of matter by physical means. So again, we can't take it apart with our hands. We can't, with our hands. We can't take it apart with our hands. So then we're going to move into a mixture. So now a mixture is a combination of different elements or or compounds, so remember those molecules, that are able to be physically separated. So these ones you can take apart. You could pick them apart if you wanted to. So there are 2 kinds of mixtures. There's homogeneous. Remember, homo means same, 2 of the same or like. And this would be samples of mixtures are composed of multiple substances evenly. So these are spread evenly throughout their mixture. So a picture of this, we're going to make sure it's even. So we're going to separate it into little like quadrants or squares of 4. And it's separated evenly. So each box is going to get a Mickey, which is our mixture or our compound. Or sorry, molecular compound. It's a molecule. You can put them wherever you want. It doesn't matter where they are as long as it's even throughout. So each box gets one. And then I'm just going to add an element. And again, they can go wherever. They just have to be even. So every box has a molecular compound and every box has an element. So it's even throughout. Examples of this would be things like ketchup. You can't take out the different parts of ketchup. Like you can't physically separate it. You'd have to do it by some other means because it's just like mixed throughout. Like you don't have like little red particles of the ketchup over here. There's better examples like salt water. If you've ever been in the ocean, the salt water is like mixed throughout usually, unless something weird is happening or going on. But you can't, like, you don't just see like chunks of salt floating around in the ocean. It's all mixed together. And no, a glacier or like an iceberg does not count. That is still frozen water. So no, not an iceberg. But the salt water, if you're ever swimming in the ocean and there's waves, you're never going to get hit by a chunk of salt. Yes, you can taste the salt and you know it's there. And when you dry off, which would be separating it by physical means because you're drying off, the water is evaporating. So that's how it can be separated. But when you're in the salt water, in the water, you like can't tell that it's separated. And there's not saltier parts of the ocean than other parts of the ocean. We're not talking about the Dead Sea, that's different. But if you're talking about the Pacific Ocean altogether, there's not different salinity contents of the ocean. Another example that you might be more familiar with would be Kool-Aid. Once you mix it all up, I'm not talking about the sugar part because sometimes the sugar stays at the bottom. But once you get it all mixed up, or if you get the prepackaged ones in like the Capri Sun containers or whatever, the flavor is all mixed in with the water. You can separate it by boiling out the water again, but that would be separating it by physical means. So Kool-Aid, once it's all like mixed up and together, would be another example because there's not, you don't take one sip and it's more like Kool-Aid-y than the same sip from the same batch before you add anything to it. Like if they were just getting it from a juice dispenser, you don't take one sip from the same cup that has more flavoring than the other, or you don't get like a chunk of just the flavor once it's all mixed together. You'll see the difference. So then the other kind is a heterogeneous mixture. And this would be samples of mixtures are composed of multiple substances, but are not evenly spread out. So this is where there are chunks or there are like separate parts. So again, just to make sure that it's not evenly spread out, let's divide it into quadrants or squares. And now every square should not have the same thing. So you should be able to tell that they are different. It's not evenly spread out. They all get something different. So examples of this in the real life context would be things like vegetable soup. You could pick out all the carrots in your vegetable soup if you wanted to. You could pick out all the celery. You could pick out the noodles. You could pick out, if it was chicken noodle soup, you could take out the chicken. So that's where there's clumps or things floating around and you could separate them. And they're not evenly spread out. Like you might have more pieces of celery than pieces of carrots. So they're not evenly spread out. Another thing might be the Chex Mix. Like if you really like the pretzels and you don't get enough pretzels compared to like the little Chex or so on. And you can also like physically separate them and they're not evenly spread out. You might get more pretzels than Chex, you might get more. If it's a trail mix, you might get more like peanuts than pretzels. And then another example would be like Lucky Charms. There's always more of the plain than the marshmallows. And there's always a different kind of marshmallow that has more than the other one. So that's all the different kinds of mixtures and matter. And then hopefully next time we are together, we'll be moving on to law of conservation of mass, and there is a lab with that.